Welcome back, everybody out there. We are still live in Friedrichshafen, Germany, here at the BASF stand at Fakuma 2021. And I'm really excited that we have our first expert discussion right now, so I won't be alone. We're going to be talking about the topic of materializing e-mobility ambitions. So it turns out nicely that I have a colleague who is an expert on materials, e-mobility, and who's also ambitious to tell us more about that. Thomas Bayerl, good morning.
Hi, Richard.
Hi, how are you today?
Fine. I'm glad to be here.
How does it feel to be back at a real trade show?
Oh, it's wonderful. Yeah, to see all the customers, all the colleagues, and I'm happy to be here with you for our new expert wall. This is our new showcase, the eMobility wall. Okay. May I explain to you how it works?
Absolutely, but I mean, normally when we're talking about e-mobility, BASF is also very big when it comes to battery materials. So maybe we start with the battery materials.
Let's do that.
Okay.
So it's basically a showpiece where we show all of our solutions. In the center we have a digital virtual car, and then you can click on battery efficiency, or you can give me the name tag and directly pops up what you want to know about. So let's start with the battery.
Okay.
So here you see our solution for batteries that's well known, our cathode active materials. It's from our catalyst colleagues. We are building a large site in eastern Germany at the moment, and basically the magic happens inside. So you don't see it really from the outside. It's the cathode material which is inside. And this is something which will really shape the e-mobility in the future.
So that's really pure chemistry inside.
That's pure chemistry, definitely.
Okay.
Yeah.
What else do we have in store?
Let me show you something else, what you might also already know from the combustion engine. So nothing to do with e-mobility, you might think. This is our coolant solution. That is the glycentine. You might have filled that in your car, but the colleagues there also have a solution for electric cars.
Okay.
Yeah, and this is the new glycentine for electric vehicles, and also that appears here in our e-mobility wall.
Okay, but this was battery materials and fluids.
Yes.
But we are still at a plastics show.
I hope so.
Where's the plastics staying?
All around.
Show me some plastics.
All around, and I mean that's why this is so beneficial for our customers, to see what does BASF offer, and we link that together with the know-how from the other colleagues to our plastics know-how. So let me change that quickly for you. So when we have been talking about the glycentine, and the glycentine has to go through some sort of piping. And this piping you might see here, this is an example. And of course it has to be that the glycentine and the piping material need to work together. Yeah, the glycentine should not be contaminated, and our piping should be, the material should be reliable for ages. Yeah, and we check that directly with our colleagues from glycentine, for instance, and derive the best and develop the best solutions for our customers.
So the point is actually having all these different solutions under one roof also increases the speed in testing.
Of course.
Okay.
And it's a big benefit for every customer who's working with us to use our know-how, which is not the plastic material know-how by itself, but the full BASF competency.
System solution. Okay, and what other kind of materials, what other solutions belong to that whole system competence for electric vehicles?
Yeah, let me show you something else here on the other side. Maybe you can put that back. So here we have something which might be a bit more far in the future, but a very interesting stuff for trucks. This is a part from the fuel cell, and this fuel cell part is made of A3WG10, which is an ultramid, so a polyamide, which is highly stiff, and makes a lightweight design for fuel cell cars. We have also in this wall integrated a nice video on all our solutions for fuel cells. And the real part, come on, I show it to you here.
Okay.
this is not as light as you might expected it.
Yeah.
It looks very heavy, very rigid, and the trick is not only that it has to be very stiff, it also has to be very pure. Yeah, because you have all.
Why is that?
You have all the fluids going around, the hydrogen, the coolants, and as I already mentioned, they must not be contaminated. Yeah, and there are also so-called media distribution plates attached. We offer a special grade which is of high purity, so that the contamination and also the damage of the fuel cell materials is not a problem for users.
I mean, Thomas, in former times, I remember when we were talking only about internal combustion engine, diesel, for example, lightweight was the main selling point for plastics in a car. What has changed?
Yeah, it has changed that currently it's more or less finding the right material for the spot, because everything is so dynamic. Yeah, eMobility, it's the strive for what is the right material. Is it metal? Is it plastics? Is it something else? It's not only about lightweight, it's the right material at the right place. Yeah, and so it is so quickly changing. Also to strive for better battery performance, which is a very pure chemical decision, but also to get everything together so that the system itself is the best working one.
So you just understanding the material, just being a plastic expert is not enough anymore. You also need to be a battery expert and a car expert and a fluid expert.
Correct.
Yeah.
You need all the competencies coming together, working together to find the best optimal solution. So something I wanted to show you as well is here below. This is something which looks like a metal, but in fact it's a plastic housing with a metal coating. And that is why, because it is metal on the outside, we need here a solution for, this is an inverter housing, we need a solution for electromagnetic shielding.
EMI,
so you have interference, which is, can be problematic in the car, so can disturb the e-motor or the passengers. Yeah, think of the heart. So you have to shield the electronics which are inside, because there are electric fields, magnetic fields, where plastic is transparent, and so you need a shielding solution.
Okay.
And this is something we work together with a partner on to have a solution on how to substitute also metals, because currently this is a pure metal domain.
Okay. I mean, Thomas, it's great that you answer all my questions, but of course you can also ask Thomas some questions. Just use the LinkedIn chat function or send us an email to plas.com@basf.com, and then we will pick them up directly here in our talk, and you are going to be ready to answer them. I got two more things that I heard about that I'm interested in. One is thermal resistance and flame retardancy. What about those topics?
Yeah, flame retardancy is something which is more and more important, because you have more electric live wires in the car, and so the danger of ignitions from these electrical components, that is a real threat for an electric car. That's why a lot of customers demand flame retardant materials, and this is also what we offer. For instance, we have this here in our charging cable, where we offer flame retardants or connectors, but I think I have a colleague who will talk on that tomorrow in this live stream. So I don't want to say too much about this. I think you can take it up with Patrick Frey tomorrow.
Yeah, we will definitely talk about that. It's going to be tomorrow at 2 p.m. I'm pretty sure. Just right over there, we'll be talking about this wall box installation and about what's inside around the wall box that a lot of people actually have in their homes by now. You only answered one of my questions. Thermal.
That's true.
What's the second one?
So thermal question about, is an electric drivetrain really cool? I would say yes and no. There are parts which are quite cold. Yeah, like in the battery has a maximum temperature of 60 degrees Celsius. But when you come to the e-motor, the temperature is around 150 degrees Celsius, so which is quite closer to a combustion engine, but you have both of them. But there's another problem with thermal, or challenge with thermal. I want to show you with our new bus bar holder material.
Okay.
Put that back here. And this is the bus bar holder.
Bus bar holder, okay.
Bus bar holder material. That's about thermomechanical stress. So here you have the normal climate changes, what a car experiences, and of course you have to have your live wires, as I already mentioned that. But in many cars these live wires are not flexible; they are rigid, and this is what you have here as a bus bar. And these live wires, they have to be attached somehow. They have to be attached somehow, and that's why you need a bus bar holder material, which is thermally, electrically isolating, of course. And we recently developed a new elastolan, a new TPU for that, which has a very good elongation, so it fits very well to the metal, because the metal makes a lot of distance during the thermomechanical stress, and so you have less risk of cracking. It's a very aging resistant material, and of course it's flame retardant.
Okay.
Yeah, which is also a must here, because we have really high voltage connections here.
Exactly. Come on, let's go back to the screen now. One thing, I mean, you mentioned all of these different solutions that BASF has in store for electric vehicles, for new mobility solutions. I would like to know how has the cooperation, the conversations with customers changed now that the industry is in such a transformation process?
Yeah, we have a lot of very intimate discussions with our customers. We talk openly on eye level. That's very important. So when we don't understand what the customer really needs, then we cannot offer our best product for this solution or for this question. And of course, we always offer co-creation workshops, to work directly on the things which are really mandatory to do, because there are some of the applications where there is so much potential for plastics and for other, to make it simply different, but better. Yeah, and that has changed. Yeah, so that customers come to us, don't order just the material, but ask us, hey, I have this and that problem. Can you help me?
Exactly, and that's why you need to understand the whole system. So Materializing eMobility ambitions is working through co-creations and through that broad material portfolio. Thomas, thanks a lot for these insights.
You're welcome.
You're going to be around, you're going to be co-creating a little more this afternoon, and we are going to be back with our next live stream here at 2:30. We'll stay exactly here, but we'll be talking about TPU for charging cables for electric vehicles. I'm going to do that together with my colleague Mark Ottens. Until then, I encourage you to participate in the live action here by using the LinkedIn chat function or our email address at plus.com, basf.com. Stay healthy, stay positive. See you later.
BASF. We create chemistry.